Yeah, okay. Good evening once again to all the participants of this today's lecture. Once again on this Friday evening from the Bureau of Indian Standards. We welcome you all for this weekly lecture series about a 3 months program which we are organizing every Friday as lectures on National Building Code of India and its various parts and sections. Well, we are doing it exclusively for the MOU partner institutes of the Bureau of Indian Standards. And we are also taking this opportunity based on the interest being received to live stream it through the YouTube channel of the Bureau of Indian Standards to enable that the expert lectures being made by the authors of the building code themselves reach out to the masses. So that is the idea with which we are doing this program, and more importantly, students who are the future professionals, they should know as to how this building code should be utilized as and when they complete their graduation or post graduation and come to the industry or field. More importantly, the building code, as you have been hearing in the last 3 lecture series, has got provisions for researchers, academicians, government organizations, other professionals, government implementing agencies, private researchers, and for everyone. The building code has got a lot of technical provisions in it, particularly from the academia and in the research background. You can contribute to further revisions, updates, and of the provisions. So that to that extent, the building code has got enough amount of flexibility, and it can address to the requirements of all the people. Before I would formally request the expert speaker for today, Engineer Amandeep Gargji, I'll just take sorry 2 more minutes to just highlight shortly about this part 6 background. Okay. Of course, the speaker for today will be formally taking us through. This is a good picture in the sense it gives a lot of information for us. This is a building, a high-rise building, which was there earlier in Turkey-Syria border. And what had happened 2 years back, I guess all of you must be aware, there were back-to-back 2 earthquakes. And this is what happened. You can see from between the previous picture onto this, which is next to a petrol pump, onto this. The petrol pump is very much here, but this building alone got totally tilted and collapsed. But all the other buildings are remaining. And there are some links in this particular one will be, anyway, you can see these links later on also. There are some interesting facts about the failure of this building. Like this was the initial plan. 156 units were to be constructed as residential in this in 3 separate towers with a common underground parking. But ultimately over the next year, there was a change in the scope of the building. It got converted into one long block and one additional block. This is always permitted. This is always doable. Only thing we have to re-engineer. Did they do this re-engineering or not? That is what is given in the link down below. But I'll just mention what are the perspectives. The person, the municipal advisor, what he said, number one, because at local level only all the building plans, their services, their structural drawings are all submitted and they are examined and building construction permit is given. The municipal advisor says, such a complex building, I do not have the software. That is one perspective. The other person, the inspector who has to go to the site every now and then, right from the foundation pit depth and then up to every floor casting level, he said, I have signed many papers, but not of this building. Most important is from a faculty researcher he said that why wait until earthquake? This is a puzzling building. It should have fallen off well ahead. Till date it was there. That itself is a miracle because there is a lot of structural issues in this particular building. There is no continuity of vertical structural member up to the foundation level. And more importantly, the contractor or the builder, as in NBC part 2, which we say, he says that I followed the codes, but the regulations were insufficient. This view of the builder is particularly was not in a legally correct sense. Ultimately, it went into legal tussle, and then that particular owner was again put behind bars, and all those legal things happened. Unnecessarily, people were put to danger, and even some of them lost their lives also. Of course, in our country, we do all these things. We follow very much the engineering practices, and then considering the flora and fauna, we ensure that the good buildings are happening. But we are also planning for all these worst cyclones or other lightning and other thunder, etc. So, but the Indian standard provisions say in IS 875 or in IS 1893, which is getting revised, all of these are giving you safe provisions to ensure that your buildings are safe. This is a simple jointing issue. The structure is intact, but it was not secured to the parapet wall. So it just flew away during the cyclone. So I'll stop here. All these can be very much avoided if, for example, the detailing practices can be done by the person, the structural engineer, the site engineer, etc. So these things should be avoided. So what as a building code is this BIS giving to each one of us, say as a student, as a professional, or as a researcher, etc. To explain to us about this building code provisions, I am formally excited to invite our engineer Amandeep Garbji, who is the managing director of Creative Design Consultants and Engineers Private Limited, who is based in NCR region in Greater Noida. He has his own team of more than 45 engineers and other architects and professionals, and he is very much a member for more than 15 years, if I remember, as part of the various standardization committees in the Bureau of Indian Standards, be it on earthquake engineering CD39 or CD7 on structural design, and importantly, he is a member of the many panels on the NBC on structural design. With these, I request Engineer Amandeep ji to take us through this presentation on structural design and give his words of wisdom, please.
Thank you, Arunji. First of all, greetings to all the participants. Well, as Arunji has indicated, how important the structural engineering considerations for any of the structures of the country, as the matter may be, that the structural safety is so important for everybody. When we cross any bridge or when we live and sleep in our homes, do we doubt that our structures will not survive? We have full confidence and faith that whatever built environment we are using, it will be good enough for us and it will give us complete safety. As we consider that the basic needs, shelter is the most important aspect of the survival or the safety. So this safe shelter comes with the good engineering, good structural designing, and I would say good execution in all respects. I will be discussing more on the structural concepts. Here, I am not going to teach the structural engineering subject, what we learn in our engineering colleges. Here, there is no mathematics. It will be only the concepts that we will be discussing, because it is very important to learn the basic mistakes we do and how we can avoid these simple ignorances so that we do correcting whatever is required. So with this, I take my presentation. Okay, so as Arunji has already explained that National Building Code 2016 is the prevailing National Building Code, and in part 6 we deal with the structural design for the structural safety. Now this part 6 has 8 sections divided as per the requirements and the steps, but what are all required to be followed for a good structural designs and selection of different wood building materials. Out of this section 1 talks about loads, forces, and effects. Now, why these 3 terms we will discuss, because generally in engineering college, what we learn is dead load, live load, wind load, snow load, only loads. So why we have these forces and effects also added in this title? So we are not only just dealing with the loads, but there will be some other aspects which are very important for the structural engineering in a way that it should survive its design service life. Generally, what happens that when we have if we consider our human life, it is expected that human life should be 100 years. If it is more, that is a grace. Like what we should get is 100 years. Similarly, for the buildings also, we should have some defined life. For large infrastructure projects, we may have target of design life of maybe 150 years or 125 years. For normal buildings, we may target to have a design life of maybe 60 years, 75 years, or 90 years. So how we design it, how we construct it to reach that level. Generally, this is not our perspective to see the design life. Generally, what we see is the strength, that this is the requirement of the strength, and we are meeting the strength requirement. So we have to look ahead from those basic things, and we will be discussing today how we can deal with these things and how our Indian Standards National Building Code is considering all these aspects in directly or indirectly guidelines. So we will be discussing about section 1. Then section 2 is about soils and foundations. Now this is a very, very important aspect where we will be discussing here today about this foundation systems as such, though the soil investigation, the soil bearing capacities, the challenges of the soil. This is again a very big aspect. So we will be just touching it, but definitely we should not ignore this aspect that soil is a black box in our system, because superstructure you can design with fairly known parameters, but for soil definitely we have to investigate more and more so that we know more about the soil behavior under different circumstances. So the soil and foundation aspect is again a very, very challenging subject. We will be discussing that. Then we come to the structural materials which we are going to use for the constructions. Generally, we are passionate about bricks and the concrete, right? But we should know that there are better or different construction materials for different types of circumstances. No single material can be good for everything, right? There will be some merits and demerits of different construction materials. And our Indian Standards and National Building Code tries to cover almost all important building construction materials. And the important area of conventional construction materials is the timber. If we see hundreds or thousands years back, the construction was with timber mainly. And even if we see the hill stations like Shimla, or if we go in northeast upper areas, what we would see is very nicely made houses of timber or bamboo. Now, in engineering fraternity, many of us would say that these are the non-conventional or non-engineering materials, that how would we design it? We do not know how to calculate the forces and how to make the design of that. So I must say that they should read this National Building Code of India, wherein complete details, guidelines have been provided for the designs with timber and bamboo. Besides the basic flexural strength, tensile strength, compressive strength, you can see a lot of information for the connection designs as well. So we will be touching on the timber and bamboo designs also. Then section 4 talks about masonry. Masonry, we all know that generally we use brick masonry. Generally, clay, burnt clay, masonry bricks we generally use. But besides that, in many of the areas of our country, we use uh, stone masonry, block masonry, and so many other construction materials for the masonry purposes. Then we have concrete material, which is properly engineered material. Nowadays, everybody recognizes it. And in concrete, we have plain cement concrete and reinforced cement concrete. And when we have plain cement concrete, we have small structures wherein we may not require reinforcement. And in important structures, generally we are using reinforcement. Now, in reinforcement, at this moment, we are currently talking about steel. But it is not that only steel can be considered as reinforcement. Reinforcement could be some other wood materials also. And now we have Indian standards for stainless steel. We have glass fiber GFRP bars. And maybe in near time, we may have some other new good materials which can be used as reinforcement in the concrete. At this moment, we would be discussing more on structural requirements and steel considerations for the RCC. We have pre-stressed concrete also. And what is pre-stressed? It is a system wherein we compress the steel, we compress the concrete with the help of steel wires or tendons so that we can control some deflections and we can improve some properties, and generally preferred for large span structures. In bridges, it is very common to use, and now in buildings also, where we have large spans, we are using pre-stressing in maybe beams and slabs also. So we generally call it as PT beams and PT slabs when we talk about buildings. Section 6 of this part 6 of National Building Code talks about steel. Now this steel is the structural steel. Generally in our engineering colleges, we study how to design using IS 800. So this section 6 steel or structural steel gives us the guidelines that how we can design using this structural steel as a building material. Section 7 talks about prefabrication, systems building approach, mixed and composite construction, and a sort of new concepts of the faster constructions. Wherein this section 7A talks about prefabricated concrete, and in 7B it is talking about systems building and mixed composite construction. The idea is that we should use newly developed techniques for faster constructions, modular constructions, and in that area prefabrication is a faster way of construction, and National Building Code covers this kind of construction activities as well. Coming next is section 8, which is glass and glazing, which was the chapter added in 2016 first time. Earlier, the glass was part of small windows and small, you can say parapets or some kind of railing systems it was being used, but gradually glass has gained more importance and popularity for large scale facade systems as well. So as the use of glass was increased, the structural safety was also to be ensured because the glass has very different properties. It is brittle and can allow very less strain. So special structural requirements, structural detailed design requirements were required. So this section 8 was developed, which covers the complete detailed guidelines of using glass or glazing as a structural elements for the buildings or any other structures. Now, coming to the load forces and effects, section 1 part of this part 6. In this, generally, we consider about different types of loads. So the NBC guides us about different loads that we have to consider. IS 875 as such gives us proper guidelines about how to take the different loads and effects into the design calculations. As our current way of structural design is the force-based design and prescriptive nature, so we have to calculate everything based on the available codal guidance of loads. IS 875 part 1 is about dead load, or the it is basically giving the densities of different materials so that we can calculate what would be the dead load on the structures, or maybe sometimes self-weight of the permanent structure. Part 2 is the imposed load. IS 875 Part 2 guides us that for a kind of building which may have different areas and different applications, a building may be a simply dwelling building, a building may be an office building, it may be an industrial building, it may be a hotel building, it may have different special requirements, it may have large kitchens, it may have large libraries. So for different functional uses, there will be difference of loads, which will be the imposed loads. So IS 875 Part 2 guides us that for a given proposed building, what kind of imposed loads we need to consider. Suppose it's a library building, stacking is there, so the loads will be higher. If it's normal residential building, the live loads may be lesser. And if it's an industrial building, the loads may still be very high. So this code guides us for different, so for a small building, all the floor loads have to be considered fully active. But in multi-storied buildings, we may have some kind of live load reduction also when we design the columns and the foundations. But for the floor design, for a particular floor design, we have to consider the complete value as given in the code to be considered as imposed load. So in a building, it is not just the dead load is the self-weight. There are so many other dead loads which are part of the building design. In engineering colleges, generally we consider the self-weight as the only dead load, but you see the many finishing loads, flooring loads, and sometimes some other special loads are there, some hanging, you have some MEP ducts, you can have some fire pipes, fire safety, hydrant lines, and so many other things which are permanently attached to the building. And for that also you have to consider them as a dead load, or sometimes it is a kind of superimposed dead load. And for live load or the imposed load, we have clear guidelines in Part 2. And then we come to wind loads. There are many areas in our country where we face big high wind speeds and storms like cyclones and so many things. So all these forces have very, very disastrous impact on the building sometimes. In Odisha, in eastern coast of the country, every year we see a lot of storms which destroy a lot of property. So we have to see that we design safe in terms of wind safety also. So Part 3 of IS 875 provides us the detailed guidelines, and this is all covered in National Building Code also, that what should be the basic wind speed to be considered in different parts of the country, and how we have to calculate the applicable wind forces. So Part 3 talks about that. In some part of our country, there is snowfall, especially in Himalayan regions. And for that area also, we have to calculate the wind impact of snow into the buildings. And for that, a complete detailed guidelines, which was revised in 2021, ICS 75 Part 4 gives us complete detailed guidelines. And this aspect is covered in National Building Code of India also, that how we have to calculate the snow loads when we design our building. Now, we have talked about dead load, live load, wind load, snow load. What is left is basically, one is the earthquake load we have not discussed at this moment. And there are many other, I would say, forces and effects. Now, we have tried to cover these special loads or effects in Part 5 of IS 75 as part of National Building Code, which talks about some kind of overturning loads effects. Then you have some temperature effects. Now you might be aware that a building, if it is very long building, suppose a building is 60-70 meter long, and if we are making it as a one integrated monolithic structure, then there may be chances of some cracks in the building just because of thermal effects. So what our code guides is that for a building having larger lengths at every 45 meter or so, we should be having a expansion joint so that our buildings remain within a length wherein the effects of temperatures are taken care automatically with the help of our basic guidelines, what we are giving for the structural design. If the building is designed normally as per the codal provisions, the effects of temperature will be taken care without any additional requirement of analysis or any additional requirements of any other design. However, if you have a building, say 50-meter long, and it's kind of special building wherein you do not want to provide a expansion joint, then how can we make it? So code allows us, enables us that we can do it, but if we have to do it, we will have to analyze for the temperature loads or temperature effects. So the National Building Code gives us the details that how we have to consider the effects of temperature. Similarly, there will be some kind of hilly terrain construction wherein there will be the foundations at different levels is the practical consideration that we cannot avoid. And there may be some kind of, say, liquid retaining structures or some other structures which are integrated as a part of the main building. So for all these kind of complications and complex effects, details of loadings have been given in part 5 of the IS 875. And mostly the all critical requirements are specified in National Building Code as well. Now coming to the earthquake. Now for earthquake loads, now first question again coming to me is, though we are designing earthquake safety as a force, but is it really a force? Yes, anybody? Is it really a force? Wind is a force, we can see that because wind pressure will be there and it will exert some force on the building, and that we have to take care. But when we talk about earthquake is because of the ground motion, and it is the inertia. It is the inertia which creates the force into the building. So if two buildings will just same in geometry, but one building has lightweight material, other building has heavyweight material. So what would be the force differentiation? The lighter building will have lesser force, heavier building will have more force. So it is an effect, and based on the building configuration, geometry, and the loads which are dead load, live load, all these aspects have to be taken care into the calculation of earthquake forces. And for that, IS 1893 gives us the details that how we have to calculate the earthquake forces. Now, this earthquake force code, earthquake design code IS 1893 has been in revision and recently published the IS 1893 code in a very different manner, because now the concept of earthquake force calculation is being changed, and this 1893 part 1, I think the code has been just recently gazette notified, and this part 1 would be talking about the general earthquake design considerations, and part 5 would be talking about the building earthquake forces calculations for the buildings. So these are the new developments which are going on. I am trying to share whatever little I know about all these things. BIS will update you more because there are a lot of changes going on. Many standards are under revision, and in near time to come, there will be a lot of improvements in so many structural engineering aspects in all the domains. Now coming to the construction materials. Now, when we talk about materials, masonry comes first in our mind because masonry has been traditionally used. So in masonry, when we have to design safe buildings with the help of masonry, especially unreinforced masonry, IS 1905 gives us very good details, and our National Building Code 2016 covers all the details all the structural requirements in details for the masonry design. So IS 1905, I would suggest that every engineer should read once, because generally this standard is missing in our college curriculum. So 190, because in our urban, non-urban and rural areas, lot of buildings which are not high rise, maybe 1 or 2 story buildings. These are constructed with masonry structures, load bearing constructions. And I would say that more than 50% constructions in our country has been with masonry, and our engineering colleges have not been teaching. So it is a very comprehensive, very excellent document for everyone to read, and one can easily understand the basic concepts of IS 1905 for masonry structure. It talks about your slenderness requirement, masonry brick strength requirements, your mortar selection, and opening requirements and all. So this is the good document if we have to design for the load bearing masonry construction. Now, to make these masonry structures earthquake resistant, this IS 4326 guides with some special detailing that how can we make these load bearing constructions to be earthquake resistant. So a lot of bands are provided, strong bands. At this moment, we are talking about RCC bands at different levels. And probably a lot of research at IITs are going on with other sustainable materials as well. That how can we provide this earthquake resistance in the masonry simple low cost buildings with such sustainable materials at lower cost and having adequate requirement of performance. Coming to other course, this IS 10440 is about reinforced brick and RBC constructions, reinforced brick concrete construction. Though this kind of concrete is now no more in practice in new construction, generally we are not using this kind of thing. But to understand the old buildings, understanding of this code will definitely help, because when we see 50, 60 years old buildings, many of the buildings, even in urban areas, we find RBC constructions. In fact, recently also we have been given a task of an old building for the renovation and audit assessment. And when our engineer visited the project site, it is in the Lothian zone near near India Gate, and that building has the roof system with RBC. So it is not that this standard is no more existing for the use. This standard is still very implementable, because we see older buildings also having this kind of constructions. Then we have IS 13828. This standard is also part of National Building Code, because when I am talking about National Building Code 2016, so I am trying to cover the different aspects of structural safety which are covered in National Building Code 2016. So when I am talking about a specific Indian standard, this Indian standard is part of National Building Code and specifically giving structural design requirements. And this is very important standard when we want to improve the earthquake resistance of an existing building. When I talk about IS 4326, it is for a building when we have to construct a new building with load bearing construction system, wherein what we should do to make it earthquake resistant, that we can take it from IS 4326. But for the existing buildings, if we have to improve the earthquake resistance, we can definitely use IS 13828.
Sir, just one, as you sip your cup of tea, one question and one update. The question is to the participants, to the students and faculty members. I remember during my time and your time also, we studied 1905 or the basic masonry design. In how many of your colleges and institutes particularly is masonry design being taught? Just give a thumbs up on this WebEx, or you can put it in the YouTube also, because we are live streaming it. And that is one thing. And second thing, sir, you just mentioned about 1893, and I was checking up. As we have started this lecture, both part 1 and part 5 of 1893 2025, the revision on the basic design, has come out in our eSale portal. As we'll be finishing this particular lecture, we'll be giving that link also, how to download the latest edition of 1893 on part 1 and part 5. The earlier part 1 got subdivided into 2 standards, part 1 general and part 5 on buildings. Just an update, over to you, sir.
Yeah, thank you, Arunji. So it's a good news that it has been uploaded in the portal, and now everybody can see the part 1 and part 5 of IS 1893, which is now in a different format, in a different shape, and it's very logically explained the calculations for the earthquake forces. Now coming to the popular standard IS 456, which we have been using for designs of RCC structures. plain and reinforced concrete structures. So lot of things here. I will be discussing many things further in this session. So it is the basic code which guides us that how we have to take care of the bending moment, flexural forces, your tensile forces, shear forces, torsion, and in plane, out of plane, lot of forces and bending moments. So all these things we have to deal for the design of the buildings, and that is being taken care by IS 456 guidelines. IS 13920 is again a very important document. When I will be discussing about some important aspects of earthquake safety. This standard, earlier it was published in 1993, and during my graduation phase, it was just a recent update that something is called ductile, and before that it was not a concept in the engineering fraternity, and then it has been updated in 2016, and again a lot of improvements are being done for this kind of ductility parameters. So this document gives us a complete detailing system which can help us in earthquake safety. So I will be talking about during some discussions. So the crux is that we have in our country a lot of constructions which are non-engineered and which are engineered. So which are non-engineered constructions? Which are the non-engineered constructions are those constructions which are not following the engineering principles, structural design parameters, and these are traditionally built based on the wisdom of your maybe artisans or whatever, whosoever is making. Maybe sometimes we call them mason, Rajmistri, or whatever. So it is up to them that they are deciding, and the building owner do not know how to construct, and they just give the work to the to some agency or some mason or some expert so-called who has no engineering knowledge, but they have learned it through their traditional construction practices from their fathers and forefathers. Now, these are non-engineered construction, and some people still believe that this is good enough for their small construction. But I would like to mention here that, of course, if there would have not been change in the construction systems, probably those non-engineered constructions could be accepted. But now everybody wants more space, so the thickness of the walls are getting reduced. People want larger space rooms, so spans are increasing. So with those changes coming up in the construction, without any computation of the forces and the bending moments and the engineering know-how, somebody may go wrong based on their experience. They cannot compensate the requirements of these thinner construction and the larger space constructions. So we have to see that all the construction of the country move towards engineered constructions, and in engineered constructions, when we call it, whether it is of masonry, timber, bamboo, or anything, it has to be a thoughtful design, calculated forces, calculated risk, or calculated safety. I would say if we know that what we are making is having this kind of behavior, or it will have this kind of performance, then probably we will be going in a right direction. So we have to move towards engineered construction. And for the engineered construction, what should be our aim? Our aim should be that the structures should perform satisfactory. They should live satisfactory. They should perform satisfactorily during their intended service life. I have used word intended service life because some structure, as I discussed, we may require, suppose some structures may be temporary construction, maybe for 5-10 years life. Some may be for 50, 60, 80 years life, and some may be more than 100 years life. So whatever is the intended service life, this structure should perform satisfactorily. So this should be the first aim of the engineering design or construction. Second part is the sustain all kinds of loads and deformations of normal construction and use. Why I have used word deformations also? Generally, we calculate for the forces, but there will be some deformations as well. Due to temperature, we will have some high temperature expansion, winter season shrinkage. So there will be some deformations. There will be some ground movements also. Now, we will be discussing further also, but here I would like to point out that when we have a bearing capacity, soil bearing capacity defined, it is defined with some ground settlement. There is nothing called zero settlement SBC. So when we talk about different foundation systems, we consider thoughtfully that for a kind of foundation system, what could be the allowed settlement, and for based on those settlement assumptions, we have to calculate our SBC. So when normally a soil consultant investigates and calculate, there are two different parameters. One is the shear strength of the soil and other is the deflection. So we have to be safe in both the way. So there will be a lot of movements in the buildings. So all these buildings movements or deformations should be controlled, and this construction should be able to sustain all these loads and deformations. Now, third part is the adequate durability. Now, if we have designed a building for say 60 years, and after 10 years of construction, every alternate years, if the building requires a lot of maintenance cost, huge work is to be undertaken for the building safety for a lot of maintenance purposes, even then the purpose is not fulfilled. The engineered construction should have a system wherein the maintenance cost should be minimal. It should perform good during its intended service life, and of course, periodic maintenance is required for everything. So periodic maintenance will be required, but it should be able to have given adequate durability in the design. Then last but not the least, it should have resistance to effects of misuse and fire. Now, when I say misuse, it is not the intended misuse, but the unintended misuse. Like during construction, you have put some material on the structural floor slab that some construction, some brick lot is made to put on the structural slab, and that is not as per your structural design live load, because when you are calculated the live load, it was the live load during the usage of construction of the building, but the building is under construction, and during construction itself, sometimes in some part of the building there may be some higher loads than the design loads. Similarly, even during usage of the building, suppose the building has been made for certain purposes and some stacking is done. Suppose it is a residential building, but some storeroom has been created within and some clothes are put, and the design load may go maybe 5% additional than the design load. So it should be able to absorb all these kind of variations or misuses. And of course, the safety from the fire is very, very important. When we use the calculations, we design the forces for earthquake, wind, dead load, live load, so many things. But fire is an incident or accident which can happen, and we should have our building materials and designs to take care of this fire safety as well. Though utmost importance is being given for the fire safety designs, that there should not be fire at all, whether it is electrical electrical installations or maybe some fire safety equipments we are providing in the buildings. All these things are there, but still, if there is a fire for small time, it should not badly affect the building as such. So building is for 100 years life or maybe 80 years life, and a small fire of half an hour or 1 hour should not affect the balance life of the building. So that is the intention, and that should be taken care during the structural design session.
Sir, if I can ask you a question here.
Yeah.
There are reported incidents of fire in some building, be it residential or in commercial building. What is the actual procedure that we permit the continued occupancy after that fire incident? Is it simply the firefighting and replacement of any electrical, or what is that which should be done?
No, it's a very, very important question you have asked, Arunji. Generally, what happens that after the fire, generally we see a lot of dark smoke is there in the room, and then after the firefighting, people just clean the room and change the electrical installations and start using the building as such that nothing has happened. But I would like to mention here that because of the fire, what happens is that if the fire has been strong enough that it has given heat to the RCC elements, maybe columns or maybe slabs or maybe beams, this heat, if has given a higher temperature to the RCC elements, it can reduce the strength of these structural elements to a greater extent. Like it can badly affect the concrete strength also, as well as it can affect the strength of the reinforcement steel inside. Because nowadays what we are using is the steel of higher grade, say maybe 500 grade or 550 grade. And if this kind of steel goes at a temperature, say more than 400 degrees centigrade or 500 degrees centigrade, and then when it cools down, the strength of this bar may not be the same. It can go down by 10 to 20%. And sometimes in the exposure of higher temperatures, the strength may go down to a level of maybe 30-40%. So overall strength of the overall load carrying capacity of the structural members can go down. And I would suggest for any fire incidents after the incident, there should be some structural audit. It should check the RCC elements surface, that what would have been the impact of this fire, and only after assuring that the structural elements are adequate enough to use it as per the required function, we should go ahead. Otherwise, all the required strengthening, because sometimes this strengthening may not cost much, but can add a lot of value to your life of the building and the safety. So based on the structural assessment, if required strengthening or some measures are required, one should do it, and then one should go for using the building.
Okay, thank you, sir.
So now coming to the wind zonation map of India, we have divided our country into these 6 wind zonations, wherein you would see this, some areas are, especially red areas, are the very high wind zones areas. So this red or pink areas, or the East Coast specifically, if you see, undergoes periodic, every year we get some windstorms or cyclones or something like this. So based on the past recorded data of wind speeds, this zonation map has been prepared, and it gives the basic wind speed. So our code guides us that how we should calculate the wind forces based on the wind speeds, and the wind speeds we have to consider as per the wind zonation map. We have a wind cyclone map of India also, and we can make use of this also if we have to be very near to the coastal areas or the areas where the cyclones occur. Now coming to the disasters or the devastations we get from the wind forces or wind effects, we see in this picture that this uprooted columns are visible in these photographs. Now, generally what happens is that when an engineer not having much exposure how to design for the wind forces, generally when they design it for the gravity loads and for small buildings or small sheds, generally the gravity load is very less, because if it is having a sheeting has very less load, these steel structural members have very less load. So maybe you are getting, say, 1 ton load at the base for a column. Now for 1 ton load of a base, now maybe you are requiring 300 mm by 300 mm size of footing, 1 feet by 1 feet. Now for this kind of situation, if we have ignored the wind load implication, then we can see this kind of bifurcation. So what happens when there is a wind? The wind provides thrust. Now because of this thrust, there may be one side compression, one side tension. Suppose this is a portal. If there is a wind, my right arm is going up and my left arm will go down. So this effect can be there. If the wind is from this side, it can have like this. If the wind is from this side, it can have like this. So one column may be in compression, one may be in tension. So because of wind, some kind of forces would be increasing on one side and there will be some tension on the other side. Now wind has another property. Now when wind blows over the building, it gives the uplifting effect also. Now if there is a strong wind, it will give your building a uplift effect. And because of this uplift, suppose if there is an uplift force of more than 1 ton per column and your gravity force was only 1 ton per column, then you will see this kind of picture, then your system will be completely uprooted. So we have to avoid this kind of scenarios. We have to simply check all the buildings for the wind forces as well. It is not that in our colleges, if we have seen dead load and wind load and that is good enough. No. For earthquake experts, earthquake engineering experts, they would say that earthquake is the must. And I would say all disastral forces we have to consider. It is not only dead load, wind load, earthquake load, snow load, temperature load, or maybe some other loads and effects would be there. So an engineer has to see the completeness of the forces that the building can have. Now you see this photograph. This is a simple portal frame system. And in our colleges, generally we learn to design how a portal has to be designed. Right? For the wind forces, for the dead and live loads, and we design the portal. And what is generally done is, suppose we have a portal at every 5 meters. So we take the design loads for 5 meters, design one portal and repeat. For many of our PV structures also, this practice has been in common, and in many countries, this practice is being followed. Now, at few designers generally do the 3D analysis of these structures. If the buildings are complicated, different spans varying, then of course 3D modeling generally people do. But for simple portal design structures like hangars or these kind of warehouses or normal buildings, generally people do the portal frame analysis and design the portal and repeat it. Now what happens is that our code and National Building Code suggests that in that case, we have to provide some bracings at adequate distances, adequate spans, so that if the wind, because we have designed for this kind of wind, but if the wind comes from the orthogonal direction, longitudinal direction, then what would be the capacity of your structure? Because other direction, you have not tied the system in a proper way. There is no proper resistance for our structure to resist that orthogonal force. So we have to provide the bracing. Now in this structure, what we find is this bracing is missing. So engineer has done almost 99% work by doing everything. Just 1% missing work, which is the bracing he has not given, or maybe the designer would have given, but the execution person would have missed it, because I have seen in some of our projects wherein we have given in our drawing proper bracings, but in execution people just forget it and they try to cover it without bracing. So we have to ensure that some of you may be execution engineers, some of you may be design engineers. You must ensure that all the required bracings have to be provided. They play a very, very important role for the stability.
Sir, on this, I have a question.
Yeah.
The codes and standards in the country, they want that particular structural design engineer who has made a bid for RCC or for steel element to go and verify on the site also periodically. How is it feasible, number one, and whether it is being practiced? And if it is not feasible, say a professional is sitting in one part of the country, say in Noida, and the project is happening somewhere in Bangalore, what are the ways and means to ensure that all these critical aspects are still addressed?
Very, very great point. I have been trying to address this situation of actual practice, this professional practice to be corrected everywhere. At this moment, the current practice is, I would leave Maharashtra because Maharashtra may have something better arrangements, but in most of part of the countries, what we find is that structural engineer gives the design drawings and his role is over. The drawing goes to the execution team, and at the execution site, there is one engineer generally, or one or two engineers who may be at a learning level, they may be having lesser experiences than required, and they have to deal with the execution. Now, with that, the execution completely goes into the hand of the execution agency, the contracting agency. Now, again, the contracting agency do not have adequate skilled manpower to take care of the building requirements. So something is missing in this chain that is required for ensuring the compliances. So there is one aspect that you have told, that the structural design engineer should take the lead. The design agency should take the responsibility of periodic inspections and do the needful as per the site requirements. So this is the ideal condition. It is the wishful condition that we should do it, because if the designer has designed it, he knows what are the requirements and he can periodically go and check it. So in places like NCR, if the consultant is also in NCR and the project is in NCR, then people do it. In Maharashtra, Mumbai, I know that consultants do it, but I am not aware that many part of the countries whether they are doing or not. Now coming to the resolution, how to resolve this issue? Now, if the consultant cannot go and check periodically, then what should be the next option we should have? Now, next option we should have is the project management consultants approach. For the projects, we should have some consultants who should have the responsibility of the correct execution. Now, they should be made accountable for the correct execution as per the structural drawings. And if they find any lacuna or any error or any problem with the structural drawings, they should communicate back to the structural engineers and check it, verify it. Sometimes they may be right, sometimes they may not be right. If the drawings are correct, then they can go it. And if they have any doubt, they should come back to the structural engineer and they can always discuss that, look, our site conditions are not matching to your drawings. So please ensure or please recheck whether we should go ahead or not. So that kind of accountability, responsibility of the project management consultants can further encourage to go for a good quality and safe constructions. Now, suppose for a project, even if the project management consultants are not adequately available or competent enough or something like that, then my wish is that all the structural design consultants should make an arm within their organization that can be called as inspection team. And that inspection team, in our organization, we have developed such team that wherever the client requests us that they do not have adequate PMCA support, they do not have any adequate engineering support from their side or contractor side, and they want a structural engineering firm or the firm to give support, this inspection team should be available to guide the project team, because sometimes in remote areas you may not get all these things. So consultants should be able to provide this support through their inspection teams. So we can have in our country these 2-3 models, maybe all available, or maybe 1 or 2 models may be strengthened for the implementation so that we get adequate safety.
Thank you, sir.
So we move ahead. Now we see this photograph wherein we see the structural frames are adequately safe, but the sheets have flown. Now, this is also a scenario I have seen practically in my life. In Rajasthan, we had developed a big area, and the construction was in progress itself. And though we were as a consultant visiting the project monthly basis or like that, in between, because it was under construction, so some people had put some sheets on their warehouses or the factories. And a strong wind came suddenly and without any warning, without any forecast, and it flew away a lot of sheets. And I would say that it was such an effect that the sheets which flew from one part of the building could reach almost half a kilometer away also, putting danger to a lot of other people who were on the roads, because this metallic sheet, heavy and very sharp edge sheet, when it was flying like a kite, it could harm so many other people also. So it's very, very risky thing. So what is the problem here? Why these kind of things happen? Now, what happens is that in the structural engineering, when we design, generally many structural engineers design for the portal system only. And they say that fix the sheet as per the requirement. Because sheet thickness and fixing details, etc., generally structural engineers were not considering as part of their scope. It is just the sheet and the contractor should fix it. But it's a structural element. So because we have in India, I have shown 6 different wind zones. So there may be different severity of the wind that the sheeting has to face. So the fixing detail, the anchors which are fixing, because earlier days there were J bolts, then other kind of fixing systems have come, magic screws are there. So how to fix it? That it should not give your water leakages inside, so it has to be fixed from the ridges. And then what should be the thickness, length of the anchor, and what should be the spacing of the anchor? All these things need to be calculated based on the wind zonation system. The thickness is also sometimes becomes inadequate if your spans are more or something like that. So sometimes you have to increase sheet thickness also, because sometimes it is not just the failure of the anchor, sometimes it may be a failure of the sheet itself. So you have to see that what should be the thickness of the sheet and how we have to make the fixing. Now, through this photograph, I just want to show that it is not that the standard drawings or these lattice towers, which are standard everywhere constructed, are safe everywhere. And these standard lattice towers have been made and have been in practice for construction and usage for so many years. These are BI, generally BI towers. But sometimes a building which comes besides it, so now there is some construction and besides this lattice tower, a building has come up. Now, what would be the effect of wind? Now, if the wind is blowing in this direction, then there may not be any issue. But if the building is coming and the building is restricting the wind, then there may be some eddy wind forces created. And if the wind rotates and if there is eddy formation, then what would happen? There will be a lot of torsion which can come into the system. Now, this lattice tower may not have been designed for that torsional force. And that is how it can badly affect the safety of these towers. So we have covered the wind. Now coming to the earthquake aspects. Now we see this zonation map of India, wherein some circles are shown. You would see these circles are spread all over the country. These are the recorded past earthquakes in India. So these are the recorded past earthquakes, and the smaller circle means smaller earthquake, larger circle means larger earthquake. So you see in the Himalayan band, there are so many earthquakes and many big larger earthquake also. But in the other part also, country's other part also, a lot of big earthquakes have happened in the past. So we have to design the buildings for the proper earthquake safety. Now, if we see this building, what we are seeing is a small building with failure during the earthquake. These are the photographs of the Bhuj earthquake. Now, what we want to learn from this photograph is, because you would have learned the concept of soft story or weak story. When we have stilt floors, sometimes we have soft story. It is not that all stilt floors would have soft story. Stilt floors have tendency to have soft story. Soft story means your stiffness difference, the upper floor stiffness and the lower floor stiffness difference is large. So based on the stiffness differences, the building oscillation may vary. Stiffness is resistance to deformation, right? So the building upper part has different resistance to deformation and lower part has different resistance to deformation. So what would happen during an earthquake? Now earth is shaking and now building will also try to shake as per their stiffness with that earthquake force. And within the building, if there is stiffness variation, then what happens is that some part of the building oscillates in a different manner and the other part of the building can oscillate in a different frequency or different time period. So what happens then? Suppose the lower part is going this way and upper part is going this way. This can happen because they are oscillating not in sync. There is no synchronization of the complete building because the stiffness is a variation. So lower part going left and upper part is going right. Then what would happen? It will be shear force or a tearing force. When we use scissor or knife, what we do? We have a tearing force which gives us the result. So in the buildings itself, we can have experiencing of this kind of forces. Lower portion going other direction, upper portion going other direction, and this is the situation what we see in this building. So how to avoid this kind of thing? National Building Code and our IS 1893 guides us that there should be no such soft stories created in the building. Earlier, some engineers were having the approach that let us strengthen it. If we have soft story, let us make the soft story strong. How much strong? Say 2.5 times strong. But it was tested and verified that even 2.5 times stronger system may not work. So ultimately, the opinion has been framed that we should not have soft story at all. Right? Now coming to these photographs. Now, when we design our buildings, sometimes we provide shear walls, strong columns, moment frames, and so many other things to resist the earthquake forces. Now, in this upper picture, you see there is a lift core which is very strong RCC system. And the left hand side of the photograph, you are seeing there is a building which is 1 story lower. So it is not that the building is 1 story lower, it is basically because of the failure the building is looking at 1 story lower, but actually the building was up to the lift wall, the core wall where you are seeing the 5 stories standing. Why it happened? It happened because this core which was designed to help the building could not help because there was no proper connections. If the connection is not proper, then how would the shear wall take the shear force? And when I was taking this lecture in a corporate training, and then we went to site to explain the things at site, and there was one construction going on, and there it is the recent time also. Well, don't see that these are the Bhuj earthquake photographs and these constructions are 20, 30, 40 years old. No, I'm telling you 1 year back experience. And when we went with the participants to this site, and I just told them that you just check the reinforcement, how it is going into the shear walls and how proper connection, whether it is being done or not. And they all were surprised that the reinforcement of the slab or adjacent structure was just touching the shear wall. Okay. Hardly 100 mm inside the shear wall. And it was just, there is no bend, there is no anchorage, there is nothing, no proper reinforcement. It was going like this. And in some portions, concreting was already done, and in other parts, the concreting was being done. So you see that whether, I do not know, it is the ignorance of the designer or the construction team. But if this would happen, then what will happen during earthquake? This will simply come out. Because there is no proper anchorage, the force will not be transferred to the shear wall. And when it will simply come out, how this strong element will help. Right? So this is the thing we need to learn and we need to implement. Similarly, coming to this bottom picture, now it is again a very good learning for all of us. And I would suggest that there should be some mechanism where we can avoid RCC water tanks over the Mumti. Now you see the photograph, there is a staircase and there is a staircase Mumti, yeah, right? Roof Mumti. And then over that, there is a water tank. Now what happens actually? Well, I would say that we have put a bomb on the escape route. If there is an emergency, from where people will try to come out? From the staircase only. And if the staircase is not safe, then what would happen? We have put a RCC water tank over the Mumti. Now, this Mumti is supported by 4 or 5 or 6 columns of the staircases. So building stiffness up to the terrace is different. And the 4 or 5, 6 columns which are going up to support the Mumti, the stiffness changes. And over that, you have a very big lump mass. Now, what would happen when there will be an earthquake? When the ground will shake, the whole building may be probably shaking in one mode, and the Mumti in probably the other mode. And then, in case of earthquake, when people would try to escape from the staircase, this kind of failure if happens, then the purpose is defeated. Some people say that for small buildings there is no risk of the earthquake. But I am showing you the two pictures that even a small building, the government building, railway station building, if the structural systems are not proper, if the construction is not good, if the design is not proper, then anything can happen, even for the smaller buildings. Similarly, for other buildings as well, we can see this kind of images, which are eye-openers for all of us, that when we do not make proper connections, when we do not take care of the earthquake forces, or when we do not take care of the other forces as well, where I was telling you about, there will be some deformations, there will be some kind of aging effects also goes into the building, and if you are not maintaining it properly, then the building deficiencies can result in a lot of challenges. Some people say that the regular buildings, small buildings do not have any risk. Now, this is a very small octagonal, or I would say circular type of building, which is supporting on a very regular system. Now, this building has also failed in earthquake. Now, there is a clear-cut indication why it has failed, and this is a very special photograph which can teach us a lot of lessons. What we do at site, sometimes we apply our mind and do something which is not given in the drawing. Sometimes we say that we have strengthened the system better. We have made more robust. We have put some additional connections. And now you see, it is very well clear from this photograph that because of this staircase, which is holding this structure, this regular structure, because staircase is an external element, it's holding this structure at one location. Now, when there is an earthquake, now you have folded something like this. So this is a box, I have folded it like this, and if there is an earthquake, it will shake like this. So this farthest part will have a lot of amplification. If this would have not been there fixing, then it could have movement like this. But because we have fixed it from somewhere, so it has moved like this. So this correction of the staircase has not helped, but has made this building fail during the earthquake. So we need to imagine in our mind that how the building would have its deflections or deformations when there will be an earthquake. And the earthquake force can come from in any direction to any phase. So as we could see, as Arunji has shown in the beginning also, there was one photograph wherein we could see one building failing and other surviving. Similarly, this photograph also gave us that picture of clarity that if we make good buildings would survive. If we will not make or design good buildings, the buildings cannot survive or would have to be failed. So at same location, one building has failed like pack of cards, and the other buildings are surviving without any damage. So it is who is creating? We all engineers. We all engineers are responsible for failure as well as good performance. If we are not doing good work, we would see what is in the left side, and if we will do good thing, we will create something for the country which is on the right side.
So the moral of the story you mean is read the Indian standards and read the building codes and do your design and your site work and execution also as per the Indian standard. Thank you, sir.
So quickly, another 5 minutes, I will try to take some more points. So ultimately, we have to be competent enough to do a good thing. For that, we should have good attitude, skills, and knowledge. So this BIS has been continuously striving to put more knowledge, skills for the participants, and you participants should have the attitude to learn and implement. So if you would implement all these skills and knowledge, then definitely we will be in a safer hands. I would now quickly take you through some slides which are part of my presentation, but will not discuss much, but would be helpful for you to have some insight about these things. So for good engineering development, we should have a holistic approach of having good design, selection of site, concrete technology, or whatever system of structural designs we are having, drainage, waterproofing, inspection, maintenance, all these things have to be there. Earthquakes, we have discussed a bit. This is the earthquake zoning map. Our country is having zone 2, 3, 4, and 5. And the recently revised code, which is just a few weeks, maybe last week only, it has been gazette notified. It has added zone 6 also. So we would be now having zone 2, 3, 4, 5, and zone 6. So these are the conditions of our earthquake. And I just discussed that heavier buildings will have larger earthquake force, lighter building would have lighter, because mass is also important because it is the force which is created because of your inertia, and inertia is mass into acceleration. If you have larger mass, then you will have larger earthquake force. And if the earthquake is high, if the ground acceleration is high, then the force will be higher. So some slides are just to explain about this inertia process. Some moment, this response reduction factor is the approach in the structural designs. So it is basically applicable for the structural designers, would not take much time for that. So these are the things which are used for earthquake force calculations. Time period, natural time period of the building is important to understand. The code gives you the formula to calculate the estimated natural fundamental time period, which can be used for the calculation of the force. I must tell you that at this moment we are designing based on the force system, but it may not be very far that we would be designing in a different approach, wherein we will be not calculating based on the force, but would be calculating based on the deformation or deflection or performances. So it is now high time that we should understand that we have to develop ourselves to have more knowledge about earthquake and the effect of the earthquake into the buildings. So these are some slides which guides us how to calculate, and attributes to perform well during an earthquake. Our structural system should be very robust. As I told, we should not have any scope of soft story or weak story. There should be some good lateral elastic stiffnesses so that our deformations are not too large. There should be some required adequate lateral strength so that in case of lateral deformations, our building structural element should not fail. It should have adequate strength and it should have adequate ductility. Now, ductility is very important to be understood, and many people do not properly understand the ductility, but just do it as per the guidance. So I just want to have one statement of ductility, that ductility is a kind of property given to a system which will allow deformation without failure. So by providing ductility, we are allowing the deformations, we can allow more drift or deformations, but the structure will be stable, sustainable. So for economical design, for high performance design, adequate ductility in the system is going to help us. Now, some people would say that Taj Mahal or many other buildings which were constructed hundreds of years back, those buildings have not been designed with ductility, then why IS code or our systems is pushing for the ductility? So we have taken some slides for that we can have both systems. One is strength-based system and other is the ductile system. As per IS 456, we can design it. But the difference is that when we have strength-based system, our structural elements will become very, very thicker. Your requirement of steel will be high. And then during an earthquake, if the earthquake force is slightly higher than what it has been designed for, the structure will fail. But when we provide ductility will allow lot of deformation. It saves a lot of money also in terms, because your structural element sizes reduces about. You have just provided your junctions to have a kind of excess of stresses also. Generally, when we do design in elastic zone, we restrict our stresses in the elastic zone only. But when we provide ductile detailing, our stresses can go beyond your linear action. It can go to the non-linear action. It can have some kind of deformation at the junctions, and some steel can yield. And because of the yielding of the steel, a lot of energy that has come from the earthquake can be absorbed, and your building can be saved from the failure. So there may be some connections which would get broken because there will be some yielding at some locations. Otherwise, building will be safe. So you are saving money as well as you are providing better safety. That is why we are insisting on ductility. So I will not take much time. These are some comparisons that how ductility can help. The energy absorption in ductile system is fairly high. The area, what we see here, this is the hysteresis loops, which are giving you good performance when we are designing with the ductile design. In case of non-ductile design, this hysteresis loop is not well defined and your structure can fail very quickly. So in this slide, you would see that the bottom part, the flexible part or the ductile part, has a lot of energy absorption capacity, whereas in the strength-based design, you have very less capacity for the energy absorption. So Generally, what we find without earthquake, probably we feel good with this strength-based design. But when we are in earthquake zones, we cannot take chance. So these are some earthquake safety requirements. I am just skipping. We have a special code for tall buildings, which is IS 16700, which gives us the structural system, the analysis part, the detailing part, all these special things which we are requiring for buildings having more than 50-meter height. These are covered in IS 16700, and this is also very important when we go taller. And these are the special requirements, ductility. Now coming to the hazard map of India, wherein we have floods also to be considered during the designs. So how to take care of the flood? We see this kind of images in our televisions in the month of July, August, when there's heavy rainfall and many areas are under water. So for that, we have IS code also that, and we should have proper safety for the foundations, because what we see generally that the soil or earth below the foundation moves and the buildings come into the distress. So if we know that these are the flood prone areas, we have to take care of the foundation as well as superstructure. We have landslide areas in our country. We have very many hilly areas where our mountains are not strong enough to hold, and during rainy season some landslides also occur. So we need to create an environment where we do not enter into any development which is landslide zone. So if we see the risk of landslide, we should not just put any construction there. We should try to save people. Now you see this photograph. There is a city developed below a loose hilly area, and see what would happen if this hillock, you see one sign of already landslide of some past, but people have not learned from that. And if another big chunk comes into this civilization, this will become a civilization of the future, because then after hundreds of years, people will say that there was some civilization there. So we should not develop those areas which are risky. We see this kind of photographs. Now, these are some of the standards which take care of the timber-based structural designs. We have very, very great detailing and design requirements given in the IS codes. And timber, you see, these are the photographs taken by myself. These are some photographs from Japan. And they have very good buildings made of timber. And I must tell you that when we are talking about earthquake zone 5 and zone 6, which are very, very earthquake prone, high accelerations, very high risk of very high earthquake forces, we need to go for system where we have lightweight constructions. And in hilly areas, we get good timber and lightweight construction. Sustainability also is there, because if you are taking concrete from say 300, 400 kilometers to construct something like that, and if you are readily having good timber there, and these are earthquake safety purpose also, it is good. So you can go with this timber system. You can have multi-story building with timber design, right?
And they are light in weight.
These are very light in weight, have very good ductility as such also, because the wood is a very ductile material as such. Yeah. So we can give good connections to them and can create a very sustainable development in the high earthquake zones also. Now coming to the bamboo, yes, of course, in our national building code, the level of detailing we have in our country probably do not have any part of the world. For bamboo, though it is ignored part of our country for building materials, but it is the most sustainable and suitable material for some part of the country where the bamboos are in abundance, and we can make good use of those. Now you see these photographs wherein you can create good constructions with the help of bamboo. Right? You see some kind of restaurants, or sometimes people say that the life of the bamboo construction is not good enough. So there are a lot of research is going on wherein probably we would be getting very high durable life of bamboo construction. But where we want 15, 20 years life of a development, at least for those areas, we can definitely go for bamboo constructions, sustainable constructions. You can have proper connection joints, everything we do for other kind of constructions. You make foundation with RCC, bevel joint, and group bamboo joints, beam column connection joints. All these things can be done. And with this last slide, I would like to say that it is not the natural disasters which kill people. it is the inappropriate built environment which collapse and kill. It is not only earthquake or wind or anything we should blame to. It is all about us. If we do something good, we can create good things. So we all engineers must strive to contribute to a built environment which is safe for the safe and habitable. Thank you all for your kind attention. Thank you very much.
Yeah, thank you very much, sir, for your excellent lecture, mentioning not only that the structural design means it is only as per RCC or steel. The building code also has variety of other options, and more importantly, there are towns and cities and professionals in the country who are doing designs using only masonry also and going for multi-stories and timber and bamboo and even glass based construction is also possible. Precast concrete also you touched about, and more importantly you highlighted the important of ask attitude, skill and knowledge. So we are in college or we are just out of the college or graduation, we have got some knowledge and we should have our attitude to continue to learn and seek, so that all our structural designs or the professional services that we are going to provide is going to be in the good intent. So excellent lecture, I would say, sir, from you as usual. And more importantly, this particular lecture is going to remain continuously in our YouTube channel also. In case our MOU partner institutes, which is more than 98 in number, of which more than 50 institutes have civil engineering and architecture. In case any student or faculty member have missed it, please visit our YouTube channel of the Bureau of Indian Standards. This lecture is going to remain there. And more importantly, it is high time that we should always go for the latest version of the building code and Indian standards and use them. Only when we have got old buildings which have to be maintained, only for such particular cases, we need to refer the old standards. Always use the latest version of Indian standards downloaded from the authentic source of BAS. Today, you can download Indian standards on your mobile as well as on your laptop or PC also. Once again, sir, we thank you formally from the Bureau of Indian Standards for this fourth online lecture series on the National Building Code of India. I hope all the participants, both in the YouTube as well as in the WebEx mode, have enjoyed it, and students particularly and the young researchers and others in the field have learned some basic lessons as well as what is covered in the code and why we should start reading the code. And more importantly, apart from the civil engineering department in BAS, we have this services department in BAS who are doing standards on multiple services, including pre-construction services, post-construction services, and construction services. There is an Indian standard IS 18299 released in 2023. It talks about structural design and proof checking consultancy for structures. And similarly, another standard was published very recently. It is IS 19235/2025, which talks about geotechnical engineering services and requirements. And these two standards have also been now cross-referred in our next revision of the National Building Code, which is ongoing. This is for the information of all the audience present here, both in WebEx and YouTube. I think we propose a formal vote of thanks to our expert speaker here. And on behalf of the Bureau of Indian Standards, we once again thank you very much, sir.
Thank you, Arunji. Thank you all. Thank you all.
So next week, we'll be meeting you again with another lecture, Friday, 4 p.m. Please do continue to join us. Thank you.